Hello, fifth graders. Time for another algebra lesson. This time we're going to talk about what happens when we put n's on both sides. Up to this point, n's have always been on one side, but in algebra that's not always the way it works. Sometimes, in fact, or often, in fact, we get a problem like this, where we actually have something like 8n plus 5 equals 3n plus 30. Notice there are n's on both sides. There's an n here and a pile of n here. But if you remember correctly from the beginning, I said that this equal sign was like a brick wall, a big giant wall that we can't go through. So I can't just take this 3n here and take it and collect it with this n because that wall gets in the way. So just like before when we had to isolate and we have to take this side away, we're going to have to do the same thing when we had to take away the 5. We're going to have to start doing the same thing with n's now. We're going to have to kind of start isolating n's. Or really getting n's on one side. So in this case, there's nothing to collect. Now it looks like there's something to collect because I have an 8n here and a 3n here and a 5 here and a 30 here. But there's not. Because of that wall, I have on this side a pile of n's and a pile of not n's. And I have on this side a pile of n's and a pile of not n's. Over here, nothing to collect. Over here, nothing to collect. So no collecting. And that's the trick about this, is now you got to pay attention to the fact that because of that equal sign, we've got to, we can't collect n's if they're on opposite sides of that equal sign. So, isolating. We're going to still isolate. We're going to pull the 5 out of there because I still need to get all the n's. The end goal is still the same. We still need to get all the n's by themselves. So I'm still going to do that. I'm going to still take away 5 from both sides. 5 minus 5, that's 0. 30 minus 5, that's 25. So my new equation looks like this. You know, I still have this pesky 3n over here. So what am I going to do? Well, you could consider it like instead of isolating the n's, I'm isolating the numbers. I'm getting this n and I want to get it over onto this side, but I can't just move it over there. I can't just collect it. I can't make this 11n. It doesn't work that way. Well, so what are we going to do? Well, just like up in this previous part up here where we have the 5 and we want to get rid of it and we take it away. Now we have a 3n and we want to get rid of it. So we're going to take it away. Let me show you what that looks like. Here's the same one from the previous slide. Looks exactly the same as it did last time. Except now I'm going to take away 3n. Just like I took away the 5 in the last step, I'm going to take away the 3n in this step. So what do I get? 8n minus 3n, that's going to become 5n. 3n minus 3n, that's going to become 0n, and it's going to go away. So what do I get? I get this. And if you look at it, this looks really familiar. This looks like isolation when we want to get down to just one n. This looks like step 3. And it is. This is our goal. From here we know what to do. We divide both sides by 5, and our n equals 25. So we've got a new step. And so we're going to change our 3 rules of algebra to the 4 rules of algebra because this last thing that I just talked about is really another step. It works like isolating, but it's really getting the n's on one side. So step 1 doesn't change. Step 1 is still collecting. Step 2 is now get the n's on one side. Step 3 is isolate the n's. And step 4 is just one n. So notice one and the first step and the last step stayed the same. I just stuck a new step in there. And the trick here, the tricky part is that steps 2 and 3 could be done in either order. So I could do getting the n's on one side first, or I could do isolating the n's first like I did in the first problem. So I'm going to show it to you both ways. Let's do a look at another example. We're going to try this one. I have 5n plus 18 equals 2n plus 48. Now, looking at this problem, I see again that there's no collecting. I have a pile of n's and a pile of not n's on one side of the equation. I have a pile of n's and a pile of not n's on the other side of the equation. Nothing to collect on this side, nothing to collect on this side. Each side has to be collected by itself. They don't collect across that equal sign. That equal sign is a big old wall that we can't go through. All right, next step. My new step 2 is to get all the n's on one side. Now, the trick is figuring out which one I'm going to take away. I could take away the 5n, or I could take away the 2n. My advice is both ways work technically. One's just a lot easier than the other. So in this case, I'm going to pick the smaller n to get rid of, because if I took away the 5, I'd have to take 5 from the other side and end up with negative 3n. And I don't, it's doable. It's legal. I can do that, but it makes my equation a lot more tricky. So I'm going to pick the smaller number to get rid of. So I'm going to take away 2n from both sides. That leaves me with 3n plus 18 equals 48. Now this looks really familiar. This looks exactly like everything we've done up to now. So now what we're going to do is we're going to isolate the n's, take away the 18 from both sides. We get 3n equals 30. This part's really simple. Step 4, our new step 4, which is our old step 3. Divide both sides by 3, and we get an answer of n equals 10. All right, I'm going to give you one more problem, and I want you to, again, try this on your own. Now, this next one is going to have some collecting in it, so I want you to pay attention to that, but I'd like you to try this on your own. Again, pause the video, try it, and then start the video up again and go through my solution and see if you got it close or right. This is the best way for you to learn how to do this. So go ahead and pause. Okay, we're back now. Hopefully you did the problem and you've got an answer that at least sort of makes sense, or if you got stuck somewhere, this is your chance to get unstuck and try to figure it out. So let's go. Step 1. There is collecting. I have a 4n here and a 2n here, and they're both on the left side of the equation. So 4n plus 2n equals 6n. I'm going to look at this side over here and say, this is a pile of n's, this is a pile of not n's, therefore there's nothing to collect, so I don't have to worry about that. The 8 is fine. Nothing new. All right. Next step. I need to get rid of either the 6n or the 2n. I'm going to pick the 2n because the 2n is smaller and isn't going to give me a negative number. So I'm going to take 2n away from both sides. 2 minus 2 is 0. 6 minus 2 is 4n. So I get 4n minus 8 equals 20. This looks familiar. I know what to do from here. I've got a negative 8, so I'm going to add 8 to both sides, which is going to give me 4n equals 28. Easy now. Divide both sides by 4, and I get n equals 7. All right. Today, when you practice, I want you to really keep a couple things in mind. Try to take away the smaller n, and when you're collecting, please pay attention to which side of the equal sign things are on. And remember that you cannot collect across the equal sign. It will mess everything up. Both sides have to balance, and if you take one from one side and just plop it on the other, you've totally thrown off that balance. So again, good luck, do your best, and feel free to ask questions if you need anything.